were able to run Docker containers, then we were using the Docker command, Docker run, and we were able to run a Docker container. Going forward, we also find that the structure or the microservices architecture would require many Docker containers to run. So we now have a capability to use Docker Compose, and we can run multiple Docker containers at the same time. But there would be cases where we probably would need to get to a level where there are so many Docker containers that we really need to understand what is actually going around, which one is running, which one is not running, which of these are actually getting resolved, mapped, and which will require scaling and all those kind of stuff, right? So a simple way where we can just go ahead and have all sorts of Dockers running and not being able to manage things was the challenge. And that is where we required a COE, container orchestration engine. So taking a step back here, till the time it is we are running all of these Docker containers onto a particular machine, like you run it on your laptop or your machine. So you would be able to run that container over on your Linux kernel or one machine. But imagine when we need a fail-safe system where we need to have these Docker containers run over to multiple machines. Like if the underlying machine itself or the server itself goes down, what will you do? All the high availability or the number of copies that we create for the same microservice or that particular Docker container is of no use. So essentially, we needed to have a certain system where the underlying layer, the layer on the bottom, where all these containers are going to run, these should be allowed to scale the system across on multiple servers. So a COE, and here in this case Kubernetes, what it did was it combined all these nodes on the back end, and all of these nodes combined, they started forming up something which is called as another layer, and this particular layer is now available for everyone to be able to see, which is Kubernetes. So one unified version out of all these multiple different nodes or bare metal servers or VMs, whatever you have there on the availability, you can use that. And with that said, now you have a unified view of what you are going to do here. So that becomes pretty important, the role of a COE that we are looking forward for. And that is why COE came into picture. So see, a lot of people will say that we had so many machines, we just needed to manage them. What is the definition of managing those machines? What is the definition of managing those containers? Exactly, what do you mean by orchestrating those containers? So if orchestration was a network resolution, a port opening, or a port restriction, all these have been happening in the past without all of these machines. And COE is not just responsible for doing that, but it is unifying all the underlying resources and bring them up and present them as a resource and or as a service that can be consumed, that can be mapped, that can be resolved, that can be terminated, that can be recreated or replicated. That's what we are looking ahead for, right? So with that said, let me see. Going to the next one. Oh, hold on. Something wrong with the sharing. I'll reshare. Okay. So out here, we said that we will get all of those on the COE. Now, specifically with Kubernetes, what do we actually get? So with Kubernetes, we get a cluster And the logical name that I was giving in here, we call it as a Kubernetes cluster. And this cluster is actually having various level of various level of abstraction. The first level of abstraction is the deployments itself. The deployments are then actually encapsulating replica sets. Replica sets are encapsulating the pods. And whereas the pods actually are running on the worker node, and the worker node has actually got the kubelet, kube proxy, and the container runtime and Docker containers, which will actually combine up and form up and run all of those specifically, right? So quickly, going over to one of my other interfaces, let's see if I have got a facility available. So all of you must have a Google account, and if you haven't activated your cloud.google.com, then you can go ahead and use your 1 year long $300 credit that comes for free, and you can go ahead and uh, do those stuff here simply just by saying create a cluster, and that will create a cluster. I'll say another cluster, and okay, my camel casing always bothers here. We can only use lower cases, so we can use whatever GKE version we want. I go ahead with the default, and when we create a cluster, as on the image that we guys saw here um, on the previous slide, that we had nodes here below. Similarly, it creates a pool of nodes, and we can specify how many nodes. It creates 3 nodes, one for the one which will manage, and the others which would be running out our load. So I'll let that be the default pool, and I'll just say create. And surge upgrade is like when you want to upgrade how many extra nodes you want in surplus. And for now, I'll let it be like that. And then the cluster creation will happen. So I'll go back to the clusters, and we'll see as soon as this another cluster
And I
gets
would like
created.
to update something here. So guys who have a little like who are actually maturing on Kubernetes, we have couple of sessions now on Kubernetes where we have detail about nodes and other details, other things. So if you find any difficulty, we'll share you those links. You can go through those sessions. They are also short sessions, and you will be able to understand. And those are the example on Alibaba Cloud and Azure Kubernetes services. So and along with that, we have already made people understood. So Deepak is trying to
Thanks,
explain
Anjali. Yeah.
core around it, right? So yeah.
Okay. So by the time this comes in, let's go ahead and have a look at this. So this cluster that gets set up, do we know how do we? Okay, good. So this cluster that gets set up here, it has got the master, it has got 2 of the nodes, and all the nodes, there would be different pods. In the pods runs the container. So I think on a high level, all of us understand to some extent of what this is, right? So uh, then let's understand what does the cluster master takes care of. Cluster master is actually having the API server, the HCD, the scheduler, the controller manager, the cloud controller manager. So these are the major components that are lying there in the master, which is responsible for managing out the Kubernetes in itself, scheduling any updates and rollouts. HCD stores all the key value pairs, environment variables, secrets, and other information that are related for the execution of the cluster. And API server is primarily the server which acts as the interfacing point for any command that you give via kubectl, you give via UI, wherever you use to give that command, it gets and takes it to the node or the pod or the corresponding worker node for the execution, wherein the kubelet and the kube proxy and the container runtime are the sub-processes on the node level. If the working on here on this level. So let's see if the cluster is back up here. We will have to refresh and let's see if we are getting that up, or is there a, okay, I'll let that be here. In the meanwhile, let's go ahead and see. Now, by the time the cluster gets launched, I just don't want to keep all of us waiting. We all talked and saw about right now that we have a node, and on a particular node, we have got pod, and in the pod, we have got container. So there is a very popular understanding that a pod is equal to container, and but I always say that a pod can be more than container. So let's understand first of all what is a node, pod, and a container relationship. So node is the underlying machine which is going to uh, create the base resources which will be available as the Kubernetes cluster for the containers, microservices, micro frontends, all of those to be executed. Now, with combination of multiple nodes, we get uh, a data plane where all these pods can be deployed. Now, that said doesn't means that uh, we do not really know that which pod gets deployed on what node. It is known and it is mapped. So when we are talking about all of these nodes and there are multiple pods getting in, so these pods could be of same type, these pods could be of different types. So let's say if I have got my application which has got number one a front end, number two a catalog, and number three a cart, number four a database for all the processing, right? So we keep database as the resource which will be storing our data, and that will be added to the Kubernetes cluster as a environment variable available for execution. But when it comes to the front end or the catalog or the cart, based on the load, these three may get multiple requests, and we may require to come ahead and um, we may be required to come ahead and do the scaling for those. So in today's session, that is what we are primarily going to talk about. Now, since our cluster is already available, let's talk about what do we really see when a cluster is available. So when we have a cluster available here, we see what are the settings that are turned on and what is the node pool here. And if we go back to the workloads, like what all is already deployed here, right now we haven't deployed anything, but from a Kubernetes perspective, there are already multiple items which are deployed here, metric servers and GPU devices and Prometheus. The metric servers would do the data collection part, NVIDIA and GPU devices and plugins, these would do GPU part of it, kube proxies and heapsters and all of these. So these are basically system resources. We have not deployed any of those. So they come under system resources. Now services and ingress, this is the point which is responsible for um, and I'll come to that one component talks to the other component, or any external user can or external service can talk to this component. That is where here is where we define that particular item. And now coming down to the applications, we can have applications from marketplace which can get deployed. We have got other configurations around the tokens and stuff, and then we have got storage. If we at all need to have a common storage or persistent storage for all the nodes and items on the Kubernetes cluster, then we have the storage class out available from here. Now, what I'll do here is on the workloads, I'll simply go ahead and deploy one of the applications. Okay. And we'll see what happens in it. I remember some of my experimental work that I was doing. There is an image, public image, and let's see if this one is still working. So I'll go ahead and deploy that. I think that's what the name is. And yeah, I'll say no environment variables, nothing. I'll say continue. Application name, let's say front end. And so we can do it here, we can write our YAML and we can push our YAML for deployment. So alternatively, we can see the YAML. So the best part for YAML to remember in the structure in terms of validation is AKMS, the API, the kind, the metadata, and the specifications. Under some cases, we may get certain more thing, but this AKMS is very, very important aspect of it. You get your API version that you need to check for, your kind that you need to check for, whether it's a deployment, it's a service, it's a load balancer, what it is, and the metadata corresponding to it, and the specs corresponding to it. So right now you can see the replicas is 3. So whatever we are going to create the application here, it will have a replica of 3. But I'll show you the beauty of Kubernetes management, what it can do here. So let's say it is doing the steps of it is using the existing cluster, creating a deployment, and yeah, and then it is waiting for the pods. So basically, pods will come in up. That's what it is doing. So how many pods do we get at this time when we launch it? We will get 3 pods because the replica set said it is 3 pods. Earlier, this replica set was known as a replication controller, which is now replica set, and whatever number we put in here, that number gets generated. That many number of pods get generated. So if we go back in here, the activity is done here. Now you see the 3 running pods which are created. Yeah, this is the front end deployment, and no data as of now because there is no activity that has happened, and this particular service is not available externally as well for now. Yeah. So I think let's see. Okay. Now, since we have the workloads here, back onto the deployment details, we can see this. No, not a create deployment, but deployments. So it should show us the deployment that we did here. Yeah, that's the deployment that we did here. Now, for any deployment to happen, right? For any deployment that is going to happen, we are allowed to take this deployment or make this deployment available to the external users, right? So this deployment that we have created, we have a port 80 and then a target port. I think I haven't tried, but I'll put a guess on 8079. And there are 3 types that we can use here. One is cluster port, second one is node port, and third one is the load balancer. So in case of clouds, we generally use the load balancer for exposing stuff. If we are using bare metal, then we can use node port. Otherwise, we can create our own physical load balancers and use that. Whereas cluster IP is the one that we use when we need to take that internally. We don't want to expose that service outside, but we want to keep it internal to our clusters only, and nothing from outside. Like for example, a database service that we would want to keep it to cluster IP itself, not to the external surface, right? So in this case, we will put a load balancer and we'll say just expose this, and that's when you'll see there is a service that gets created under the services and ingress, right? So it is waiting for a load balancer with external IP. If it gets one, then it will get created, right? So I'm not going to hold on there. Let's go back to the stuff that we were doing. Let's see. That was the original thing where we were. So HA and release strategies. Now, what does actually release strategies have to do when we are talking about the HA? So when we talk about a deployment is basically, there are 3 things that come under deployment. Number 1 is the deployment is basically a strategy. That what kind of strategy do we adopt when we are rolling out a new version? Do we need to do a rolling deployment, or we need to do a recreate deployment. So these are the two options that we have. When we do a rolling deployment or when we do a recreate deployments, in the cases of rolling deployments, the for example, I have currently 5 running pods with version V1. Okay, and we need to go ahead and say that okay, we need V2 to be deployed. So in rolling deployment, batch by batch, this will happen that there will be a V2 that would be coming in, and once the number of pods under the V2 are created, then the number of pods from V1 would be taken off, and there is a surge that will get applied there. So let's see if we have got our stuff created here. We'll go back to this. Yeah, so this is created, and we can see there is a load balancer that we have got it mapped here. And let me see if this one is really opening up. I'm not sure if that may not be the right port, but looks like there is a call that would have come in. Yeah, so there is a call that has come in, and something is there on the container that is running in. Okay. So now on the workloads part, when we talk about this particular workload, right, and this is on this particular deployment. Now, on the action, we can auto scale, we can expose, we can do a rolling update, or we can scale in. So if we go back to here, see, these two are terminating. These two are terminating because they are not in use, and this is the one which is running. So over the time, we will find that the pod running is 101, and the autoscaler is doing its job. It is just killing out the non-required pods. Now, when we talked about the strategy, these are the two strategies that we can take. Now, let's really talk about how and why do we really want to decide when we are running pod that what runs inside the pods. Because for now, we understand that pods would have the containers. So while deployment, the first thing under deployment strategy, and then comes the pods. Now, with the pods, a deployment can go to multiple pods. A deployment can go to same pod alone. Depends on what all the deployment consists of. But so with the pods, there are a couple of times when we need to run multiple containers in a pod. So if we do not talk about Kubernetes, then there are scenarios where we may want 2 microservices to run side by side within the same container, right? But the problem is that if we run 2 microservices inside the same container, then the Docker engine or the container engine, which is basically gets tied up to the logging output and the container event output, all that would be tied to one of these two one of these 2 microservices, and the other will get ignored. Or we end up writing a third microservice, which will be actually aggregating all of these information and pulling it together. Whereas Kubernetes gives the concept with the pod, it enables that you can run multiple containers inside a pod, and the pod itself will have its own the kubelet and the kube proxy layer, which will actually interact and provide that information and give that communication. Initially, if we talk about the older state where we were talking about running pods into the same container, then it defeats the purpose of auto scaling and stuff per microservice. And there are 3 different patterns that we use when we need to run containers within the same pod. Typically, when there is a sidecar container that is required, for example, there is a git sync that is required, then in that case of git sync, we may be requiring a sidecar container which always need to be replicated, or the replica needs to be created based on the load that is coming from the processing side. Second is ambassador containers, and third is adapter containers, right? So these are the 3 types of patterns that we use for pods to run side by side multiple containers within the same pod. An example for that is like Istio, and we may have heard about this so very lot many times that we can run Istio sidecar proxies, and the way it runs is that it makes its own agent kind of thing or a container running inside the pod, and it communicates back to the microservices, the other containers inside the same pod. So coming down to zero time downtimes, yeah, we talked about the rolling update and the recreate. That is our choice. How do we want to implement that? That is the most important part of it, and how do we take that forward? Now, the third part comes is service discovery, which is the next important item, which is when we have got this scaling happening all around, then how do we manage the service discovery part of it? When we going back to our console where we were doing all of these actions, if we go back to the workloads and we go on the workloads here, I see that sorry. Um, so let me remove that filter, and we see that there is a kubedns workload which actually works as a DNS system that resolves all the internal service mappings. So if there is a microservice which is coming up that needs to talk to another microservice, then the pod will register that particular item as a service, and the service gets populated into DNS, and this would be either on the cluster port, cluster IP, or it would be on the node port, or it would be on the balancer, load balancer, right? So based on its accessibility, we need to be sure about what we are choosing the option here, and based on the visibility, that is what happens. So if we do not use the service discovery, the problem is that it will get messy, that every node needs to know what is running on the other node. That is why a node port is not recommended to be used in any of the cases unless there is a hardbound or a third party or a fixed machine license kind of a software that needs to run on a machine or device lock specifically. And for the load balancers, we have all the public items running on there and the cluster IPs there. The service discovery is very much required even in case the scaling happens, because if we even decide to have a seed of names or some automation around that, whenever the auto scaling happens, it creates a lot of trouble in terms of the name resolution. So it is very much important for us to make sure that we are taking care of the service discovery. And what we could see in here on the cluster that we are using and on the workloads that we are having here. So I'll go ahead and put the filter. Name was front end, and we can see that on the scale for this particular, if the moment we specify auto scale with minimum number of replicas, maximum number of replicas, what is the threshold on the CPU that we want, or if we want a different threshold, we can do that. And if we say that, okay, the CPU threshold target is, let's say, 20, and then it will scale as soon as the node hits 20 here. And if we do this here, the HPA configuration for this is enabled automatically. We can go to the HPA configuration and see that what does it actually does that. So there is a detailed documentation available on Google itself. But if we go back to our YAML file that we have here for this particular guy, we can see here, right? And we'll find that the specs and all this is available here. There is a rolling update. There is a maximum surge available. There is a replica, right? And then there is a specs that we are giving in here, and all of those stuff are available. So that is how we can configure all the scaling requirements, the number of replicas, the apps, the links, and the exposures to all of these items, right? Uh, I think um, precisely there are a couple of key takeaways. Number one, we should be very cognizant about what goes into a one single pod, how many containers we are going to run in a pod. And number two is how many, uh, while configuring our application, what is our replica set configuration. When I say replica set configuration, that means the minimum that we need to run, the maximum that we need to run, and in certain cases, the desired that we need to run. Number three, we need to be very aware about what are the resources that are required on scaling. So one good scenario that came in was there wasn't a scaling configured on the node group, but there was scaling configured on the pod level. So when the rule for the pod scaling keeps on coming up and everything keeps on scaling up, where the underlying node itself, node group itself, falls short of resources. And that you can see on here. Okay. So we need to be sure that whatever we are running, what is the version or what is the resource requirement for all of these? That is the third part. And number four, not everything requires the highest of the CPU in the world or highest of the memory in the world. So if my microservice is memory intensive or my microservice is CPU intensive, then I should be able to define my node groups based on CPU or memory or whatever GPU, right? Whatever kind of work it is, and data scientist guys would probably relate it very well. So if they need more processing, image processing or something, there where they need GPU, or they need a lot of number crunching where they need a lot of CPU, then in those cases, probably those microservices would be dedicated to those node groups which are having high CPU, and that is achieved by using the labels and the selectors. Labels, selectors, namespaces, and annotations. So these are the four concepts that we need to understand very clearly. Labels and selectors do not create any isolation, whereas namespaces creates isolation. When we say isolation, that means the IPs, the disk space, the CPU, the memory, all of these resources cannot be shared by anybody who is not in that namespace, cannot be accessed by anybody who is not in that namespace. And annotation is used as a keyword tagged over a kind of a service or kind of a deployment that can be directed to be mapped to a particular node group kind of a stuff, right? Whereas labels and selectors are used for specific and custom functions. You can use them for cost reasons, like all of these which are this label, they come under this particular cost center, or fetch me the CPU consumption details for all of those which are under this label, and so on and so forth, right? So we can do all of those. And then selectors are again a similar kind of a behavior that is used. So as long as we are taking care of the pods and what are we putting in the pods, making sure that a pod has got 2 microservices, 3 microservices, or 1 microservice, precisely we have got scaling defined basis on the grouping on the right scenario. Now, how do you decide that one pod should have 1 microservice or multiple microservice? The question is very simple. If your both microservices can run independently and outside, and there is no overhead of network, when I say no means negligible, or negligible overhead of network calls, and they do not need to sit in together like Istio proxy needs to sit in together. But if you have a system like we were talking about, front end, catalog, cart, and database, so I don't think the catalog needs to sit with the front end, because front end needs to scale basis on how many requests are coming from the top, from the consumer side. The catalog needs to scale basis on how many requests are being passed from the front end to the catalog server, right? So that request numbers would vary, and they have their own scaling needs. There is no point giving extra resources to catalog when it doesn't needs to it. So let's keep that one out of it. So first of all, we need to be very sure that we are defining the strategy, we are answering this question and deciding that how many items do we need, how many containers do we need in this particular pod, and which are required, and then create as many pods as needed. There is no problem having multiple pods. Replica sets is the next feature where we need to understand that if we are having X number of copies of this particular item, is that sufficing in the case of when there is minimal or no load on the system? That would form my minimal value, right? Max should be always kept more than what you expect, and it should be monitored, and it should be triggered. The scaling should be triggered, and the monitoring should happen that when we are going to we are heading towards the max number of replica set when we are going to touch that, right? So that we have a prep, what do we do about it? And then desired is something which is a general behavior. We do not want a lot of our time getting to the maximum, getting to the minimum, and so on and so forth. Resources. So the third point, when I said resources, I really meant about talking about the CPUs and memories and the storage and any shared storage that you are using, any persistent volume that you are using. So all of those, right? And then labels and selectors and namespaces to make sure that those are being taken care of well, right? So I'll take a pause here. That's the conclusive part of it. We can do a lot of this using our codes, using our YAML. And why I introduced you to the Google console is because you can do all of that here. First of all, using your operations on the console, and you can always run and learn kubectl to all of these just by going ahead on launching this. If you say just launch it in the Cloud Shell itself, you don't need anything. It will do all this activity here itself on your browser. It will just go ahead and give you this editor here. It gets you connected. You can run all your kubectl commands and everything as simple as that. If you just run the kubectl, it will tell you, okay, this is all I have.
That's the real beauty of Google GCP console. That's the real beauty. And you can directly run it on the console, on the screen only. Many cloud platform have, but they have a separate screen for doing it. Here it's like integrated on the same screen. That's really innovative.
Yeah, I'll take a pause here and probably take some of the questions if they are on the chat and they are unanswered, and that's where I'll take a halt on. Yeah. So let me see. Go over on the chat.
There are a couple of questions. Yeah. So how is multi-cloud cost effective compared to single cloud or hybrid cloud and security? So it's so a little different question than what we are talking today. So let's I think we'll park it and we'll answer it later. Can be a VM node can node be similar config or different?
Nodes can be of different configurations. As I said, let's say I'm putting up an application which requires a lot of image processing and then certain data science operations over it, and then requires a front-end application which will actually present all of this. So I would definitely not want my high CPU intensive node group to be scaled just because there is too much load on my website. So I can have a node group which will have high CPU machines and another node group which can have high GPU machines. And when I say node group, there is auto scaling on the node group level where we will have either 2 nodes or 3 nodes. And let's say if there is a 3 node cluster running, that doesn't mean the 3 nodes need to be running all the time, right? So I can have a 5 node cluster configured wherein the other 2 nodes will only come in when there is as much of load as here. And when that load will come? Only when the pods which are annotated to be launched on that particular node group, those are coming up. So that is how we can manage which node group will have what resources and which pod goes on what node group.
We are a little less in time because we have another session coming up at 9 p.m. By Binayak Pandey. So before that, we take a couple of other questions before we drop up, and we may be like connected on like you can ask the question on our
Sure.
Telegram channel, and we'll pass that
Sure.
to the Deepak Singh.
Sure.
But
Sure.
yeah, so let's announce the code. So code I have sent you on the on your WhatsApp, Deepak. And
Okay. 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 Let me have a look at that.
so
Yeah.
to get the certificate for this session, you just have to go to this link. There is a Telegram channel also where if you have any issue, you can connect to. Go to https www.fifthir.com. I have typed in the chat, and then Deepak will announce the code. You put your name, email, phone number, and put the code that Deepak is announcing, and you will get the certificate. Certificates are more like a respect to the speaker, and this is where like you are giving him giving him back in terms of sharing it to different platform and regarding him, giving him well respect for a session that is well received. So that's where I would request you guys to take the certificate and do share it with your community. And there is a Telegram channel. If you find any difficulty with the certificate, if you need to know about next session, if you have to ask question with Deepak, if you're not connected with him on LinkedIn, you can go connect with this on this Telegram channel and directly question us, and so one of us will answer it.
So it's Alpha Bravo 7 machine learning.
Yeah. So it's A for Apple, B for Bombay, 7, M for machine learning, as Deepak said. It's all caps. A caps, B caps, 7, M caps, L caps. 7 is the number 7. A B 7 M L. I would repeat, it's A B 7 M L. Yeah, Deepak. Yeah, please take the next question. Is it possible to
Sure.
configure a serverless database as a node in a K8 cluster? We have another 6 minutes remaining. I think, yeah, we can take few questions.
Yeah. So is it possible to configure a serverless database? Yes, you can. That depends on what kind of your database is. If your database is having integrity issues, if there are multiple instances running, then you may not be able to. If you are creating something like Redis shards, and then you have a way to club all of them into the same system, into a same database, you can do that even in case of a write machine. So there are different patterns which you can use, and yes, that is very much possible. In case of NoSQL databases, it is required to have read operations alone or having helpers which can help serialize across machines. Yes, it is very much possible.
So no, code is not shareable anywhere. Just keep the
What
code
is
separate.
shareable, Jagnesh? Was it about the content, or is it about the key or the certificate? If it is about certificate, yes, you can share the certificate.
Yeah,
The
don't type in the
content
code,
would,
don't share the code. Yeah,
yeah,
that's
yeah,
only like you heard. Even if you don't need to type in here anywhere, because anyone who comes and watch the recording, our motto is to make people learn, right? So it's more important for them to watch the recording on our YouTube channel on Fifth IR, and they let them hear the
yeah.
code and then get the certificate. That will be a real win for them.
Yes.
They will love it, right? Because they have done some work.
Yeah.
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 Or you will feel cheated because you have your hair for an hour and then someone just seal the code and take the certificate. No use, right? So
Yeah.
a couple of other question.
Or
If I so if I
sidecar
request.
Nginx or one Nginx with multiple pod for auto scaling, which is good. Um, Sidecar Nginx or one Nginx with multiple pod for auto scaling. Nice question there is, and I would say that if your Nginx is having no logic at all, then I would say it should be it should be it shouldn't be a sidecar. It should be one container in itself, which is able to scale and take the load, wherein it can get the microservices on the back end. You can use a lot of your caching capacity, which you would not be able to do in case of sidecars. In case of sidecars, you will have to have as many replica of the microservices happening as the the logic layer or the front end layer, whichever you are putting it across. Um,
Um, how can
so
we start on Kubernetes from scratch? So obviously we have session time on time on Kubernetes, on serverless Kubernetes, on on the core Kubernetes platform like the one Deepak saw you. Uh, and
yeah,
we are also coming up with a series on Kubernetes, data science, and multiple things. Just stay tuned on our channel. We'll soon start on those areas.
yeah, very nice question that came up from Charanjit. 5 security considerations for Kubernetes. There is a Medium article that I wrote some time back, and let me see if I am able to find that. While I do that, I will also try and help you out with what is that we can do. Those 5 things. Number one is the Kubernetes container security that we need to do. The Docker container security, I would say, not the Kubernetes, but the Docker container security that I need to um, have it there, because the containers can be having security threats. The libraries being used on the Docker container, those should be scanned. Then comes the build time process. When we are building out, then that should be scanned. The penetration testing that done, that should be scanned. And the kubectl or the kube systems dashboard itself or monitoring system itself, that needs to be very well protected and secured. Last but not the least is the container runtime security that should be there on the system, so that it can identify any command which you have not whitelisted or you are not expecting that to be flagged as a detection system IDS kind of a thing that should be taken care of. So those are the primary things that we should be taking care of. And I couldn't find the article right away, but it is there on my
And
LinkedIn.
we'll post
So I
that
can.
we'll post that through Telegram channel. And so
Yes,
we
yes.
have the speaker for the next session, who is here. Welcome, Binayak. And so yeah, sorry, it was a little short because we didn't find time on Deepak's calendar. He's too busy. But obviously, will
No,
he's
thank you.
coming.
Thanks for having me here.
Yeah.
Thank you guys, and
And
post
next
out the
week
questions.
Deepak
I'll
is
take it
coming on
offline. Yeah.
Docker next. Like you can also put some question for next week when Deepak is coming for a Docker security session. You can ask your questions there, and we'll try to do a replay of at least 4 5 minute 7 minute for this session, for your pending question to be answered by Deepak. Thank you everyone, and the people who have joined for the next session, you can stay connected here. I will soon start.
Yeah, thanks so much. It was really interesting.
Yeah, so this is Dheeraj Deepak. Yeah,
Hey, thank you. Thanks everyone. Signing off now.
yeah. Thanks a lot, Deepak, for your time here. And people are asking. Some of the people are asking for code. So I will re-announce the code for the people who didn't listen. Is AB7ML for this session. Is A for Alpha, B for Bravo. 7 is the number. M for machine. L for learning. Thank you everyone. Let me share my screen for the next session. Just give me a moment. I'm trying to
Great session, Deepak.
stop the recording for this session.